As part of the previous section or module, we have gone through details related to setting up Databricks-based environment on top of Azure portal to prepare for Databricks Certified Associate Developer for Apache Spark 3.0. In this section or module, we'll actually go through the details about creating Spark Dataframes using Python collections as well as Python Pandas Dataframes. We should be able to convert typical collections as well as Pandas Dataframes into Spark Dataframes. Once we are ready with Spark Dataframes, we should be able to leverage those Dataframes and we should be able to explore most of these details. Without Dataframe, we will not be able to explore all these details, and hence even though it is not apparent with respect to the outline that is provided to us, we are going through detailed information related to creating data frames using typical Python collections as well as Python Pandas data frames. In the pursuit of that, let me go back to the Databricks environment. Let me create a folder here. A folder can be created under workspace. In this case, the workspace is under my account. I should be able to expand this, then say create, then click on folder. Now let me say 01 create Spark Dataframes using Python collections and Pandas Dataframes. Now the folder is ready. We'll go through each and every step associated with converting typical Python collections as well as Pandas Dataframes into Spark Dataframes. As part of the sectional module, we are interested in covering details related to creating Spark Dataframes using Python collections as well as Pandas Dataframes. First, let's understand how to create Spark Dataframes using Python collections. Then we'll actually go through the details related to creating Spark Dataframes using Pandas Dataframes. That being said, let me create the notebook here. So in this case, I'll be starting with creating a single column data frame using a list of elements. First, for that, let me create the notebook here. As part of this folder, let me say create notebook. Then let me name it as create single column Spark data frame using list. Hit enter. Now let's first create the list. The list name is nothing but ages underscore list. Let me assign 5 elements in this list. They are nothing but 21, 23, 18, 42 or 41, 32. Now ages underscore list is created. The type of ages underscore list is nothing but list. You can actually validate by saying type and then paste it. You can see that it is of type list. To create data frame using this list of integers, we should be able to use something called as create data frame, which is available on top of Spark object. As this notebook is created using Databricks platform, there will be Spark context associated with it. Also, there will be Spark session associated with it. The Spark session is exposed by using name called as Spark. You can validate here. It have a function called as create data frame. You should be able to say spark.create and then you can hit a tab to autofill. You can see that it have autofilled. Now you can pass this to help to get the details related to this function. So spark.create data frame is nothing but a function which can be leveraged to create the data frame from Python collections or Pandas data frames or even Spark RDDs. If you go to the help, you can see that create data frame is nothing but function. It takes several parameters. They are nothing but data, schema, sampling ratio, verify schema, etc. You can actually go through details about each of these parameters by reading the documentation under parameters. When it comes to data, either it can be RDD or iterable. At this time, we are not talking about Spark RDDs. We are talking about iterables such as Python collections as well as Spark data frames, which means we are referring to iterable. When it comes to iterable, either we can pass list or Pandas data frame. For now, we'll be focusing on using list to create the data frame. Also, when it comes to lists like this, where we have list of integers, to create single column data frame, we also need to understand details related to schema. When it comes to schema, you should be able to pass the schema using multiple ways. You can actually go to the details here. It can be pyspark.sql.types.datatype or string or list or optional. You can use either of these approaches. If you want to use the data type based upon the type of each and every element in the list, you have to determine which type should be imported and you have to import that and you have to use the constructor of it. Or you can also pass the data type in the form of string. If you just pass the data type, it will actually determine the column name using the system generated names. The default name it will use is nothing but value. Let's create the data frame so that you understand what I'm talking about here. For that, I should be able to say spark.create data frame. First, let's pass the ages underscore list directly. You can see that it is failing, saying that cannot infer schema for type this one. you have to pass the data type to actually create data frame using list of integers. Otherwise, it will not work. There is alternative way where you can actually pass list of tuples and still data frame can be created without specifying the schema. However, when you are trying to create data frame using a list of integers, you have to specify the schema. The schema can be column name as well as the data type, or just the data type. If you just pass the data type, it will determine the column names by itself. Now let me actually say spark.create data frame. One of the ways to create the data frame is by passing the schema as a string. So let me say int here. Now you can see that data frame is created. Also, we should be able to leverage class called as integer type, which is available under pyspark.sql.types to actually create this data frame. Let me copy this. Let me add here. Before creating the data frame using integer type, which is nothing but this one, we have to use constructor. However, to run it successfully, we need to import it. To import, we have to say from PySpark, then .sql, then types, then import. Then we should be able to say integer type like this. We should be able to import the integer type, then use it to create the data frame. You can see that data frame is created successfully. So in the case of converting a Python list which contain integers, if you have to create the data frame, either we can specify the data type like this or like this. Now let's perform another task so that we are really comfortable with this. In this case, I'll be creating a list by name names. Let's say names underscore list equal to, let's create the list. In this case, let's say Scott, then Donald, then Mickey, so and so forth. You can have as many elements as you want in this list. Now we have created list of strings or list of texts. Let's create this. Now we should be able to create the data frame by saying spark.create data frame. Then the first argument is supposed to be names list. When it comes to the data type, we should be able to pass string like this. You can see that data frame is created successfully. The column name is nothing but value. The data type is nothing but string. You can also import a string type from pyspark.sql.types. Let's replace integer with a string here. Let's run this. Now let's copy this, paste here. Let's replace ages underscore list with names underscore list. Let's change this integer type to string type. You can see that data frame is created successfully. As part of the next lecture, we will also see how to create data frame using list of tuples. We'll be creating data frame using list of tuples where each tuple have only one element, and also we'll be creating data frame using list of tuples where each tuple have multiple elements as well. Let's go to those details so that you understand what I'm talking about. As part of this lecture, let's go to the details about creating multi-column Spark data frame using a list. We'll be using list of tuples to create a multi-column Spark data frame. That being said, let me create a new notebook. Let me expand this, then say create notebook. Let me name it as 02, actually 03. Create multi-column Spark data frame using Python list. Now first let me create a list of tuples here. I'll be having ID and a name, and then we'll be using that list of tuples to actually create the data frame. Before getting into multi-column Spark data frame using Python list of tuples, let's also cover details about creating single column Spark data frame using Python list of tuples. So let me start with ages underscore list itself. Now if you want to use list of tuples to create single column data frame, then you have to create list of tuples like this. So you need to have brackets for each and every tuple like this. In this you can have elements, let's say 21. You also need to have comma, then 23, then 41, then 32. So we have 4 elements. Each element is of type tuple. Also I need to have comma here. Now let's run this. A list of tuples is created. Let's validate by saying type of ages underscore list. You can see it is of type list. However, if you check any one of the elements here, let's say type of ages underscore list of 2, which will actually give us the third element. We are trying to get the type of the third element. You can see that it is of type tuple. So if you have list of tuples like this, you should be able to create the data frame directly without specifying the schema. In this case, to create the data frame, we should be able to say spark.create data frame. Now we should be able to pass a list of tuples. Let me say ages underscore list, run this. you can see that data frame is created without any issues. Even though I haven't specified the schema, it is working without any issues. Now let's see if it will work or not by specifying the schema here. I'm saying int to specify the schema. You can see that it is complaining. So the syntax of passing string or data type only will work only with list of normal elements. If you have list of tuples, you can remove this and still it will create the data frame for you. However, if you wanted to specify the schema, you can specify the schema with a column name along with the data type. You can say age and then int, and now the data frame is created without any issues. This is how you can actually create a single column Spark data frame using Python list of tuples where each tuple have only one element. Now let's go ahead and create multi-column data frame using list of tuples where each tuple will have at least 2 elements. So in this case, I'm actually creating users list. Now let me assign 4 values to it. Each one is of type tuple. Each tuple contain the user ID and the user first name, let's say Scott. The second element is nothing but 2, then Donald. 3, let's say Mickey. 4, let's say Elvis. Now we have created a list of tuples. The list of tuples contain 4 elements. Each element is of type tuple. You should be able to create the data frame using this approach. Let me copy, paste here. Let me remove the data type first. Let me replace ages list with users list. You can see that data frame is created with 2 columns. The column names are system generated. You can also specify the schema like this. You can actually say spark.create data frame and then comma. Then you should be able to say user underscore ID int user underscore first underscore name. Let's say string. String is the data type for user first name, and hence I have specified string here. Now you can see that data frame is created without any issues. When it comes to the column names, they are nothing but user ID and user first name. The data types are nothing but integer and string. This is how you should be able to create either single column Spark data frame or multi-column Spark data frame using Python lists where list contain tuples where each tuple contain 1 or more columns in it. We can also specify the data types using this approach along with column names while we create the data frame using list of tuples. Make sure you are really comfortable with this because we'll be using very often to actually create data frame with multiple columns to explore most of the Spark APIs. At this time, we are going through the details related to creating Spark Dataframes using Python collections and Pandas Dataframes. In that process, we have seen how to create single column Spark Dataframe using list and also how to create multi-column Spark Dataframe using list. Now it is time for us to explore a very important class called as row, which is available as part of Pyspark.sql. Let's get an overview of row in this lecture. We'll also see how to perform operations around row. That being said, before getting into the details of row, let me run this code and make sure we create data frame by name df. The data frame is being created using the users list. The users list is nothing but of type list. This list contain 4 tuples. Using these 4 tuples in this list, by specifying the schema, we are able to create the data frame. The details of this is covered as part of the previous lecture where I have covered how to create multi-column Spark data frame using Python list. If you are not comfortable with this, make sure you review that and then come back to this. Now the data frame is created. You should be able to preview the data by saying df.show. You can actually see the data here. Now, a Spark data frame is nothing but a collection of row objects. To understand the statement, you can actually use something called as collect. What collect will do is it will convert data frame into a Python list. You can actually say df.collect, run it. You should be able to see the output here. The output is within square brackets, which means the returned object is nothing but of type Python list. You can also validate by saying type of df.collect. So let me say type of df.collect. You can see that it is of type list. Each element in this list is of type row. As mentioned earlier, row is available under pyspark.sql module. You can actually import row if you want to explore more details about row by saying from pyspark.sql, then import row. Row is imported. You can also get help on row by saying help, then row. You can see that row is nothing but a class. You have a constructor. The constructor takes 2 arguments. The first one is nothing but varying list of arguments. The second one is nothing but varying keyword arguments. So using either of the approaches, you should be able to create the row object. We will see a bit more advanced operations in the subsequent lectures of this section. For now, let's understand how to create a row using either of the approach. the first approach is to pass the varying list of arguments. The arguments can be of any type. However, it has to be varying list of arguments. We should not be having any keywords to actually satisfy this. First, let's explore how to create row object by passing varying list of arguments. Then we'll also see how to pass varying keyword arguments to create the row object. You can also see the examples as part of the help itself. This is the example for the varying keyword arguments, where you have the keywords also while invoking the row constructor. You should be able to see the example related to passing varying list as well. Let me scroll down and see the example with respect to varying list of arguments. You can see here, we just pass Alice and 11. Even this one will create a row object. Let me copy this. Let me scroll down here. Let me paste. Let me run this. You can see that it have created the row object with these two elements. You can also pass keyword arguments like this while building the row object. Let me actually copy this, paste here. I haven't copied it properly. I need to make sure I have copied it without any issues. Now let me paste. Now it is copied. Now I should be able to run this. You can see that the row object is created. You should be able to preview by saying row 2, and you can see the output here. The difference is when it comes to R. Let me print R here. It doesn't have the names of the arguments here because we have created R with just varying arguments, not varying keyword arguments. Whereas with respect to row 2, it is created using varying keyword arguments, and hence you can actually see the argument keys also here. One of the advantages of using the varying keyword arguments to create row object is that we should be able to access the values using these argument names. So in this case, I should be able to say row 2 dot name. I should be able to access the name. You can see here. Also, I should be able to access using this approach. As we read from dict, we should be able to read from the row object as well by passing the attribute names or the argument names like this. This is how we should be able to create row objects using varying arguments or varying keyword arguments. And also we have gone through the details related to converting a data frame into a list. When data frame is converted to list using collect, it will actually convert data frame into list of row objects. As we got an overview about row, now let's go to the details about converting list of lists into Spark Dataframe using row. We'll actually convert list of lists into list of rows, and using list of rows, we will try to create the data frame. That being said, we have already gone to the details about creating multi-column data frame using a list. At that time, we have seen example with list of tuples. In the similar manner, we should be able to create data frame using list of lists as well. Let's understand the details related to users list first, and then we'll actually review how we can create the data frame without converting this list of lists into list of rows. Then we'll actually get into the details about converting this list of lists into list of rows and then create data frame off of it. So let's run this. It will create a list by name users_list. You should be able to check the type of it. It is nothing but of type list. You can pick any one element in this list and check the type of it. In this case, let me check the type of second element. You can see that each element is of type list. Even when you have list of lists like this, you should be able to create data frame using spark.createDataFrame. You should be able to pass list of lists like this in the same way what we have done with list of tuples as part of the one of the earlier lectures in this section. You can see that it have created the data frame with system generated column names _1 and _2. You can also specify the schema by saying user_id int and then user_first_name string. You can see that data frame is created with the column names that are specified here along with data types that are specified here. The way we have converted list of tuples into data frame, we should be able to convert list of lists also into data frame. Let's understand how to convert this list of lists into list of rows and then create the data frame. In this case, I can actually convert list of lists into list of rows either by using list comprehensions or by using a map function. Whatever is convenient to you, you should be able to take that route and you can move forward. I'll be using list comprehensions. List comprehensions is one of the ways where lists can be processed in Python as programming language. Now let me say users_rows equal to the way list comprehension work is like this. You can have the transformation logic first and then you should be able to specify the for loop. In this case, let me say for user in users. Now I have to come up with the transformation logic on top of this user to convert the list into the row. So we should be able to say row like this. Now when it comes to user, it is of type list because the users list contain lists in it. In this case, I have to say users underscore list, not users. Once you have list, you should be able to convert to varying arguments using this approach. Let me say star here. Let me say user. However, before running this, I need to import row. Let me import it first. Let me say from pyspark.sql import row. Once row is imported, we should be able to run this piece of code. Now it will create something called as users underscore rows. It is of type list. Each element in this list is of type row. So we have converted list of lists to list of rows. Now to create the data frame, we should be able to say spark.create dataframe. We should be able to pass the list of rows, which is nothing but users underscore rows. You can see that data frame is created with system generated names. If you wanted to specify the schema, you can specify the schema the way we have seen earlier. Let me copy this and let me paste here. This is how you should be able to create the data frame using a list of lists by converting a list of lists into list of rows. Before concluding, let's spend some time to understand why we are using star user here. It is very, very important for you to understand this. Otherwise, you will struggle to actually absorb the concepts. To understand, let me define a function here. The function name will be dummy. It takes one argument. The argument is of type varying arguments. So you can pass as many arguments as you want in place of this one argument. I just wanted to print whatever arguments that are passed to this function. Let me say print args. Now I have ran it. It have created a function by name dummy. Now we should be able to say dummy of 1. You can see that the arguments are printed here. Even though I have passed only one argument, it have printed as tuple. Because we have this star at the beginning, it will interpret whatever arguments are passed as tuple only. Now let me add one more argument here. We can pass arguments which are of type anything. It need not be integers alone. So let me say hello here. You can see the details here. It have printed both 1, hello here. Sometimes when we use functions like dummy which accepts varying arguments, we might want to pass a list and we would like to process each element in the list as a separate element by interpreting the arguments as tuples. Now let's understand what happens when we pass the list directly and then we'll take it further. So in this case, let's say you have something called as user details. It is of type list. The first element in the list is nothing but user ID 1. The second element is nothing but user first name Scott. Now the list is created. The name of the list is nothing but user underscore details. Now if you say dummy and then users or user underscore details, you can see that it is considering as one argument which is passed to the user underscore details. It is not considering those as two different arguments. Many times we might have to convert the list into different arguments as the function takes varying arguments. To convert list into varying arguments rather than passing as one argument, you can actually add star at the beginning. That's where the star comes into picture here. Now you should be able to run it. Instead of passing user details as one argument as part of args, it have passed it as two arguments. You can see that it is printing 1 and Scott separately here, whereas here it have printed 1 and Scott together here. You can also say print len of args. So we are going to print the number of arguments also. If you run this, the number of arguments is only 1, whereas with this the number of arguments is 2. So that is the difference between using star and not using star here. So when it comes to row, you can see that it actually takes varying arguments or varying keyword arguments. You should be able to get the help on row. Let me add a new cell here. Now let me say help on row. You can see that there's a constructor which takes varying arguments or varying keyword arguments. In this case, we would like to convert each and every list in this list of lists into row objects. In the process of converting each of these lists into rows, we have to make sure that we pass them as varying arguments. To pass them as varying arguments, we have to use star. That's where, as part of this list comprehension, where we have converted users list into users rows, we have used star user while invoking row constructor. That is the purpose of this one, or that is the rationale behind passing user in this manner to row. It is very, very important for you to understand this. As we have understood how to convert a list of lists into Spark Dataframe using row, now let's go to the details about how to convert a list of tuples into Spark Dataframe using row. As part of this lecture, let's go to the details about converting list of tuples into Spark Dataframe using row. First, let's create a users list. The users list contain list of tuples. Each tuple contain two attributes. One is user ID, second one is user first name. You can also check the type of one of the elements here by saying type of users underscore list of one. In this case, I am trying to check the type of second element. You can see that it is of type tuple. Now, if you have list of tuples like this, you should be able to create data frame easily by saying spark.create data frame. Then you should be able to pass the list of tuples by saying users underscore list. It will create the data frame for you with system generated names. If you would like to specify the custom names, you should be able to specify like this. You can actually say user ID int and then user first name string. It will create the data frame for you. We have already seen these details earlier. Now we can also convert the list of tuples into list of rows, and then using the list of rows we should be able to create the data frame. Already we have gone through details related to converting list of lists into Spark Dataframe using row as part of the previous lecture. You have to follow similar steps even while converting list of tuples into list of rows before creating the data frame. So in this case, let me say users underscore rows. Before actually using row, let's import it. Let's say from Pyspark.sql import row. Now the row is imported. Also, before actually using it and converting the users list to users rows, let's revisit the way varying arguments work. Already we have seen a function by name dummy which takes varying arguments. Let's print arguments as well as print the number of arguments. Now let's add a new cell. Let's say dummy. Let's pass user details. So in this case, the user details will be in the form of tuple. So let me say user details equal to, I'm creating a tuple. I'm saying 1 comma Scott. Now let's run these two. You can see that even though we have varying arguments with respect to args as part of dummy, when we pass the tuple, it is actually taking as one argument only. You can also review the number of arguments. It is only saying 1. To make sure that we convert to row object, we need to make sure we convert the tuple into varying argument, then only it will work. So to convert a tuple into varying arguments, we should be able to say star like this and then run it. Now you can see that the tuple is converted to two different arguments, and you can also see the number of arguments here. It is nothing but 2. So using a similar approach what we have seen earlier with respect to converting list into varying arguments, we can convert the tuple into varying arguments while creating the row objects. So in this case, I can say users rows equal to, I am going to use list comprehensions. I can say row star star or star not star star and then user for user in users underscore list. Now you can hit enter or you can run it. You should be able to see that a list is created. This list contains row objects in it. Now we should be able to use spark.create dataframe to convert this users underscore rows, which is of type list of rows, into a data frame. The data frame will be of type Spark Dataframe. We should be able to say spark.create dataframe, then pass users rows to it. You can see that data frame is created with system generated column names. If you would like to specify the schema, you should be able to specify the schema in this manner. Let me copy this. Let me paste here. Let me run this. You can see that data frame is created successfully. So the list of tuples is converted to Spark Dataframe using row. Already we have seen earlier about converting list of lists into Spark Dataframe using row. Now we are also comfortable with respect to converting list of tuples into Spark Dataframe using row. Another common data structure which we'll be using to convert to data frame is nothing but list of dicts. Let's go to the details about how to convert list of dicts into Spark Dataframe using row as part of the next lecture. As part of previous two lectures, we have gone through details about converting list of lists as well as the list of dicts into Spark Dataframe using row. Now let's go to the details about converting list of dicts into Spark Dataframe using row. As we have seen with respect to list of lists as well as list of dicts, we should be able to say spark.create dataframe and we should be able to pass list of dicts to it and we should be able to create the data frame. However, it is being deprecated. Let me demonstrate details related to deprecation. Then I'll actually go to the details about how to convert list of dicts into Spark Dataframe via row. For that, I'm actually connecting to my own cluster. Let me move the terminal here. Now let me say SSH itversity@g01.itversity.com. If you have Spark set up locally, you should be able to use your local Spark as well. You don't need to have a multi-node cluster. If you have access to multi-node cluster, you should be able to try this using CLI. Now let me say PySpark. However, before launching PySpark, let me actually set couple of environment variables. One of them is nothing but PySpark_Python. I need to set it to Python 3 so that it actually uses Python 3. And also I would like to set another environment variable, which is nothing but Spark major version. I have two versions of Spark in this cluster. I would like to use Spark 3 for the demo, and hence I'm actually setting Spark major version to 3 here. Now I should be able to say PySpark then --conf spark.ui.port equal to 0. Don't worry too much about why I'm using --conf at this time. It is not the agenda to cover those details. In this case, I just wanted to make sure that the approach of using spark.createDataframe to create dataframe off of list of dicts is being deprecated. If you try as part of this, it will work without any issues. Let me run this, and then let me say spark.createDataframe. Then let me pass users_list. In this case, users_list is of type list of dicts. You can see that the data frame is successfully created. If I use the same code as part of the CLI here, let me go to the terminal. Let me paste this piece of code where the list of dicts is created by name users_list. Now let me copy paste this one. You can see that it is actually complaining saying inferring schema from dict is deprecated. Please use pyspark.sql.row instead. So we are supposed to use this from futuristic perspective. Now let's go to the details about how to convert this list of dicts into data frame via row. For that, first we need to import row. Let me say from pyspark.sql import row. Now the row is imported. If you look at the help on row, it takes two types of arguments. One is varying arguments. Second one is varying keyword arguments. You can actually create row objects for each of these dicts using either of the approach, and then using that list of rows, you should be able to create the data frame. However, you will be able to achieve the end goal. There will be some subtle differences which you need to keep in mind to achieve that end goal using either of the approaches. First, let's go to the details about creating rows using this approach. Then we'll also see how to create the data frame. Then we'll actually go to the details about creating list of rows using this approach. Also, we'll see how to use it to create the data frame. So now we have list of dicts. The name of the variable which contain list of dicts is nothing but users_list. Using list comprehension, I should be able to convert the list of dicts to list of rows via a function called as values. So for example, in this case, let's say user_details is the variable name. Let me assign one of the dict from users_list to it. Let me pick the second one by saying of1. Now user_details contain one dict. You can see here the dict contain two elements. One is nothing but user ID. Second one is nothing but user first name. We also have the values corresponding to those keys. Now to actually get only the values so that we should be able to use the varying arguments to convert the row, we can use a function called as values that is available on top of dict. So here I can say user_details dot values. You can see that it have returned list type object here. This is not list object, but it is similar to list. That's why I'm saying list type object. Now using this, you should be able to build the row object, and you can take it further. You can actually say row of star, then user details dot values. You can see that the row object is created with the values of that dict alone. Using this approach, we should be able to convert a list of dicts into list of rows, leveraging the varying arguments syntax. Let me come up with the logic using list comprehensions. In this case, I can say users_rows equal to square brackets. As part of the square brackets, I can say for user in users_list. I have to apply required transformation logic on user here. User is similar to user details, and hence I should be able to say row of star user dot values. Now let me run this. You can see users_rows object is created. Let me review the details here. You can see that it contain row objects in it. Using this, I should be able to say spark.createDataframe. Then I should be able to pass users_rows to it. you can see data frame is created with system generated names. We can actually specify the schema by saying user ID int, then user first name string. Now you can see that the data frame is created with user specified column names along with the data types. This is one way where you can actually convert list of dicts to data frame via row. The other way is by using varying keyword arguments. For that, you just have to say users underscore rows, row of star star, and then remove dot values. Then run this. Now users underscore rows will be created. This will be of type list. However, this time it will contain row with argument names as well, not just values. Now you should be able to say spark.create data frame users underscore rows, and it will take care of creating the data frame for you. You can see that data frame is created. However, user ID is bigint in this case. We can also specify bigint here to make sure both match. Let me actually first run this. Now using a list of row objects which are generated using varying arguments, I am able to create the data frame with user ID bigint and user first name string. This is the approach which can be leveraged to actually convert list of dicts to list of rows with column names, and then we should be able to create the data frame where user ID is bigint and user first name is string. Now let's spend some time in understanding this. Let me create a function by name dummy. Let me say star star kw args. Now let me say print kw args and also print len of kw args. Now the function is created. We should be able to say dummy. Then if you just pass dict directly, so let me add a dict object here by name user underscore details. So user underscore details is of type dict, and hence we have to specify in curly braces like this. Now I can say user underscore ID, let's say 1, then user underscore first name, let's say Scott. Now you have the dict. If you just pass dict directly, it will be considered as only one argument. It will even fail. It will not even work. You can see here. It is throwing exception saying dummy takes 0 positional arguments, but 1 was given because we haven't specified any keyword for this argument. You can actually specify the keyword like this by saying user underscore details and then equal to user underscore details. Now you have the key by name user underscore details. For that, whatever dict that is passed is considered as the value, and you can also see that the number of arguments to be 1 with respect to dummy when we invoke it using this approach. The formula of passing user ID and user first name separately to dummy is like this. You can actually say dummy, and then you can actually say user ID equal to 1, and then user first name equal to Scott. You can run it. You can see it have accepted them as 2 separate arguments. When it comes to internal processing within dummy, it is actually processing all the keywords arguments as dict only. So internally it is converting all the keyword arguments to dict. So in this case, you have to convert your dict to keyword arguments and then pass to dummy so that it works without any issues. The way you can pass user underscore details as keyword arguments instead of passing it as dict to dummy is by using star star before it. So in this case, you can say dummy, then star star. You can pass any dict object. In this case, I'm going to pass user underscore details. Now you can see that it have considered user ID and user first name as 2 different arguments. You can also see the number of arguments here. That is why we are actually using star star here to make sure that the dict is converted to keyword arguments while building the row object. This is how you should be able to convert a list of dicts to list of rows. You can either use varying arguments or varying keyword arguments. However, the process is a little bit different to achieve the final goal of creating the Spark data frame. But using either of the approaches, you can actually convert list of dicts to list of rows, and using those list of rows, you should be able to create Spark data frames. Make sure you go through those details so that you understand completely about it. As part of this lecture, let's go to the details related to basic data types in Spark. Spark also supports all different types which you typically see in any standard database or even programming language. When it comes to users, in this case, is nothing but of type list. This list contains different dicts, each dict related to a specific user. This dict is related to user with ID 1, then this dict is related to user with ID 2, so and so forth. When it comes to these dicts, the keys are nothing but attribute names. You can see the attribute names are same for each and every user detail here. When it comes to values, they are nothing but corresponding values for each of the attributes. In this case, one is the ID, Corey is first name, so on and so forth. When it comes to the structure of each and every dict in this list, it is same. It have same number of attributes, same type of values. The values might be different, but the data types are same. That being said, using this list, let's create Spark Dataframe, and then we'll actually go to the details about basic data types, which will be created as per the values that are specified here. In this case, ID is of type integer, first name, last name, and email are of type strings. You can see here. When it comes to is customer, it is of type boolean. Amount paid is of type float or double. Customer from is of type date. Last updated timestamp is of type timestamp. Let's create this list. Users is of type list. It contains several dicts in it. As we have list of dicts to create data frame formally, we can actually convert list of dicts to list of rows and then use spark.create data frame to create the data frame. We have gone to the details as part of the earlier lecture. Let's use the same here and create the data frame by name users_df. To create users_df, first I need to import this. Then I should be able to run this. You can see that in place of argument, I have passed the logic which will actually convert list of dicts to list of row objects. You can see that data frame is created. You should be able to review the schema details here. You can also use a print schema, and you should be able to see the details about the schema using print schema as well. Print schema is a function which will actually give us the details about the schema. You can also preview the data using show. Show is also function. Let me say users.show to preview the data. In this case, I am supposed to use users_df, not users. Users is of type list, not data frame. Show is the function which is there on top of Spark data frame. Now you should be able to preview the data. On top of functions such as print schema, show, etc., data frame also exposes few attributes. Using those attributes also, we should be able to get the names of the columns and also columns along with the data types. Let's say users_df here. Then say dot hit tab. There is an attribute called as columns. You can see here. So using columns attribute or instance, we should be able to preview the columns. In this case, columns is attribute or instance. It is not function, and hence we should not be specifying circular brackets here. We just have to say columns, and we should be able to get the column names. In the similar manner, if you wanted to get both column names as well as data types, you can use something called as dtypes. Dtypes is also of type instance. We should be able to run this, and we should be able to see the column names as well as data types. Now let's go to these basic data types. You can see that ID is actually transformed to bigint. First name, last name, and email are nothing but string. Is customer is of type boolean. Amount paid is of type double. Customer from is of type date. Last updated timestamp is timestamp. So these are some of the very commonly used basic data types which you should be familiar with. We have created a data frame with all those basic data types. As part of Spark Dataframes, we can actually define columns with special types as well. Some of the special types are nothing but array, map, struct. We'll be going to those details once we understand how the data types can be passed using different approaches in the form of strings as well as in the form of something called as Spark types. Once we understand those details, then we'll actually go to the advanced types such as map, struct, array. That being said, for now, make sure you understand the basic data types that are supported in Spark, and also you should be comfortable with how to convert typical collections in Python into Spark data frames and how the data types are actually derived internally. Depending upon the data that is there as part of the original list, the data types will be automatically be derived even if we do not explicitly specify the data type. Also, before moving on to the next lecture, let's review some of the records in this where is customer is false. You can see that amount paid and customer from are null. The reason why they are converted to null is because when it comes to the actual data in the users list, when is customer is false, we have specified amount paid and customer from as none. That's why they have actually translated to null values in these two records. So keep these conversions in mind when it comes to working with data structures using different frameworks. In this case, we have converted a Python list of dicts into Spark Dataframe. A Python none is converted to null values. When it comes to Python booleans such as true and false, you can see that they are converted to true and false, but in this case, they are in lowercase. So you need to keep these conversions also in mind. As part of the previous lecture, we have gone through the details related to basic data types. Now let's understand how to specify schema as a string when we actually create the Spark data frame. For this also, I'm actually using Python list. You can see there's a Python list here by name users. When it comes to this list, it contains tuples. each tuple contain exactly the same number of elements. You can see the details here. This one contain 8 elements. This one also contain 8 elements, so and so forth. Each and every tuple contain same elements, and also the types of each of these elements are same at the same position. For example, the first element in this tuple is of type integer. Also in this tuple also the first element is of type integer. In the similar manner, the fifth element is of type boolean. Even in this element, the fifth element is boolean. So each and every tuple have same structure but different values. You can also scroll down and you should be able to review last two, where is customer is false, the amount paid and customer from are nones. So we have exactly same number of elements in each and every tuple that is part of this list. Now let me create list by name users. In this case, users is of type list. Each element in the list is of type tuple. As there are no column names for these values, we have to explicitly specify the schema. One of the ways to explicitly specify the schema is by defining the schema as string. Now let me define a string variable here. The variable name is nothing but users underscore schema. Now I would like to break the string into multiple lines. For that reason, I'm actually defining this string in triple quotes. Now the first element in users data is nothing but ID. It is of type int or long or big int. You can use whatever is relevant for you. If you think that the data frame will have millions and billions of IDs, then it is better to use long. Then comes first name. First name is of type string. Then last name. Last name is also of type string. Email is also of type string. Then comes is customer. It is of type boolean. As we have trues and falses for is customer in these tuples, we have to specify it as boolean when we actually define the schema for data frame while we create the data frame using Spark. After that, we have amount paid. Amount paid is either of type float or double because we have decimals. Let me define it as float. You can also use double. Either of them will work. Then comes customer from. Customer from is of type date. Then comes last updated timestamp. It have timestamp part also. For that reason, we have to define it as timestamp here. Now I have created the string by name users underscore schema. We should be able to pass this string to a keyword argument called as schema while creating the data frame using spark.createDataFrame. Let me run this. Now user schema is created. If you look at the help on spark.createDataFrame, it takes multiple arguments. One of them is nothing but schema. You can see here. Either you can pass a second argument as schema or you can also use a keyword argument. In this case, I have used keyword argument schema equal to users underscore schema. Even if you remove this, it will work without any issues. By position, second argument is anyway schema only. Now let me run this. You can see that the data frame is created. You can also preview the data by using show. You can actually go through the data and see whether it is as per our expectations or not. You can see the data types of each and every attribute here. They are based upon whatever is defined while creating this string. You can also change this customer from to timestamp. Even though the actual values are dates, you might be able to create customer from using timestamp. Let's see if it works or not. It is not working. So from date, you cannot actually convert to timestamp because there is no time part in it. However, with respect to last updated timestamp, you might be able to change it to date. Let's see whether it will work or not. You can see that it is working. With respect to last updated timestamp, I am able to create as date even though it have time. It have trimmed the time part and it is displaying only the date part. So you can actually override some of the types by specifying the schema using different types than their original types. But they have to be compatible if you want to use some other data type. For example, you will not be able to convert a string to date or a number to date because they are not compatible. But between date and timestamp, it might be possible to convert from one type to another type while creating the data frame. We have already seen an example here. We are able to specify date for last updated timestamp and data frame is created successfully without any issues. However, when it comes to the actual data, the time part is gone. To make sure that it works as expected, let me change it to timestamp and then let me run this to make sure that everything is working as expected. So while creating the data frame using spark.createDataFrame, we should be able to explicitly specify the schema by passing the schema as string. However, if you go to the help here, Let me scroll down a little bit. When it comes to schema, it can be either of type string, or it can be list, or it can be of type data type also. So if you actually have schema which is based on pyspark.sql.types.datatype, you can actually use that also to explicitly specify the schema. Let's go through those details as part of the next lecture. As part of this lecture, let's understand how to specify schema for Spark Dataframe using list of columns. First, we have created users, which is of type list. Each element in this list is of type tuple. You can see here, this is one element which is related to user ID 1. This is another element which is related to user ID 2, so on and so forth. So using this list of tuples, I'm going to create the data frame. For that, I should be able to leverage create data frame function, which is available on top of Spark session object. Spark session object Spark will be available as part of Databricks notebooks automatically. If you look at the help on Spark.create dataframe, the first argument is nothing but data. The second argument is nothing but schema. Then we have two other arguments. In this lecture, we'll actually talk about passing list of columns to schema. On top of list of columns to schema, we can also use none, which is default. And also we should be able to leverage struct type, which we'll be seeing as part of the next lecture. And also schema can be passed as string, which we have seen as part of the previous lecture. Now, when it comes to specifying schema as a list of columns, we just have to specify the column names. We should not be passing the data types. We just have to specify the column names. The types of the columns will be inferred from the data. You can read the statement here. When schema is a list of column names, the type of each column will be inferred from data. Now, this is how we should be able to pass list of columns to schema. You see here, I have created a list. It has strings. These strings are nothing but column names. If you try to specify data type like this, then the column name will become id space int. Let me demonstrate, and then you will understand what I'm talking about here. Now you see the data frame is created. However, with respect to id, the column name is id int, the data type is bigint. So whatever value you pass as part of each of these strings, that will be treated as column name. So the ideal way of specifying the id is like this. Now if I run this, and if I run this, it is normal. The first column in the data frame is nothing but ID. The second column is nothing but first name. The third column is nothing but last name, so on and so forth. You can also preview the data here, and you can confirm the column names here as well. They are as per the list which is used to actually build the data frame by passing it as schema. This is how you should be able to create a data frame using schema, where the column names are passed as list. As part of previous two lectures, we have gone through details related to specifying schema while creating the Spark data frame using string or list. Now let's go to the details about using Pyspark's types to actually specify the schema. It is multi-step process. First, let's go to the APIs or classes that are available, and then we'll actually go to the steps, and then we'll also go to the implementation part of it. But before diving deep, let's create a list by name users. We'll try to create a data frame using this list. Already we have gone through the details related to this list earlier, and hence I'm not walking you through the details again. Now, with respect to types is available as part of pyspark.sql. You should be able to import types like this. Once you import types like this, if you wanted to review what types contain, you can actually say types, then dot, and hit a tab. You can see that there are several classes in this. You should be able to relate data type of each and every element against these types, and you should be able to use relevant ones. For example, id is of type integer. Now you should be able to search for integer in these types. You can see there is integer type. You should be able to define id as integer type using this class. In the similar manner, first name, last name, and email are of type string, and you can see string type in this. Let's scroll down and see string type. When it comes to is customer, it is of type boolean. You can see boolean type as part of this types package. You can see there is something called as boolean type. In the similar manner, when it comes to amount paid, it is of type float or double. You can see that there are multiple types which are related to float or double. You can either use decimal or double or float type. You have to experiment, and you have to determine which one you should use depending upon your requirement. In this case, we should be able to leverage either float type or double type when it comes to amount paid. Then comes customer from, which is of type date. You can see there is date type here. Then comes last updated TS. It is of type timestamp. Let's see if there is timestamp type in this or not. You can see there is timestamp type in this. So each and every field can be defined using these types. However, we cannot directly specify these types. We have to use struct field to define the field. Once you have struct field for each and every field, you have to create struct type. Struct type should contain the list of fields. Then struct type can be used as schema. So in this case, for each and every data type, you need to identify corresponding type in pyspark.sql.types, create fields with the name of the attribute and the corresponding type from pyspark.sql.types. Then you have to create the list. Using the list, you have to create something called as a struct field. Using that struct field, you should be able to specify the schema while creating the data frame. Let's go to the details so that you understand how to take care of the implementation as well. In this case, first I have to define a variable by name fields. It is of type struct type. I can say types.struct type, or we can also actually import everything from types by saying from pyspark.sql.types, then import star. Now everything from types is imported. Now I can actually say fields equal to struct type. I have to pass a list to it. So let me pass a list to it. Each element in this list is supposed to be of type struct field. So let me say struct field. In this case, the first element is nothing but ID. So let me say ID, it is attribute name. The second element in this struct field constructor is nothing but the data type. In this case, we have to use the appropriate data type, which is nothing but integer type. You have to make sure you invoke the constructor of the integer type so that the type object is used while creating this field. Like this, we have to specify fields for each and every element. We have 8 of them. So let's make sure we have 8 of them here. Now we have all the 8, I guess. Let me see. 3, 4, 5, 6, 7. We have to have one more. Now we have all the 8. Now when it comes to the second field, it is nothing but first name. So let me say first name here. When it comes to the third field, it is nothing but last name. Then email. Then is customer. Then amount paid. Then customer from. Then the last one is nothing but last updated TS. Now when it comes to the first name, it is of type string. So let me say string type here. Even when it comes to the last name as well as email, they are of type strings only. When it comes to is customer, it is of type boolean. So let me say boolean here. When it comes to amount paid, it is of type either float or decimal. Let me say float. When it comes to customer from, it is of type date. So let me say date type. When it comes to last updated timestamp, it is of type timestamp, and hence let me say timestamp. Now let me run this. It is saying invalid syntax. We need to review the details and we have to take it further. The reason why it is saying invalid syntax is because I do not have commas to separate these elements in the list. You can also expand this and you should be able to see the details here. It is complaining because it is seeing struct field instead of ending this line properly. So I just have to say comma after each and every type here. Once we have commas like this, now we should be able to run this. It will take care of creating something called as fields. Instead of naming it as fields, let's name it as users_schema. Now we have users_schema. Let's check the type of users_schema. I can say type of users_schema to get the type of it. You can see that it is of type pyspark.sql.types.struct type. Now you should be able to run this. The data frame will be created without any issues. However, it is saying length of object 6 does not match with length of fields 8. Let me see. Okay, the reason why it is not working is because these two doesn't have enough values in these tuples. Let me fix this. So here it is supposed to be none. Even this one is supposed to be none. Also here we need to have 2 more values, none and none. Now let me run this and then go through the steps to create the data frame. Now the data frame is created as per the expectations. You can also preview the data by running this piece of code. You can see that data frame is created successfully using the schema that is created using the struct type. Struct type, struct field, and all the types that are used here are part of pyspark.sql.types. You just have to import these, create a list of fields, use that list of fields to build the struct type object. Using that struct type object, you should be able to specify the schema and create the data frame using spark.createDataFrame along with the collection or list which contain the data. As part of last few lectures, we have gone through details related to creating Spark Dataframes using Python lists. In this lecture, let's go to the details related to creating Spark Dataframe using Pandas Dataframe. It also has several advantages. I'll be emphasizing on those advantages as well. First, let's create a list by name users. This users list contain dicts in it. You can see the 5 dicts here. When it comes to last 2 dicts in this list, they only have 6 elements. You can see here. With respect to this dict, it has only 6 elements. There is no amount paid or customer from in this. Same is the case with this dict. So the structure of these dicts is little bit different compared to what we have seen earlier. Let me create this list by name users. We should be able to create Spark Dataframe by converting this list of dicts to list of rows, and then by using spark.create_dataframe. That is what we are doing here. You can see that dataframe is created, and you should be able to preview the schema also. But when it comes to users df.show, you can see that it is failing, saying 8 fields are required while 6 values are provided. It is because the 2 dicts related to ID 4 and 5 have only 6 elements, while rest of them have 8 elements. And also when it comes to the schema, it have picked 8 fields based upon the first 3 records in this list. If you create Pandas Dataframe using this list of dicts, it will automatically substitute null values for the missing attributes in these 2 dicts in this list. Let's go to the details so that you understand what I'm talking about here. First, I'm importing pandas as PD here. Then I should be able to say pd.dataframe, and I should be able to pass users to it. Let me say pd.dataframe. Let me pass users to it. You can see the output here. Even though user ID 4 and 5 doesn't have amount paid and customer from, instead of throwing error, it have actually returned nan. Nan means not a number for these 2 attributes, or it is similar to null value in a database. I guess nan is nothing but not a number, but I do not remember for 100% sure. That being said, now we are able to create Pandas Dataframe even though some of the attributes are missing in some of the dicts in list of dicts. Using this, we should be able to create Spark Dataframe by saying spark.create_dataframe and by passing the Pandas Dataframe. Now we should be able to run this, and we should be able to get the dataframe as per the expectations. You can preview the output here. Also, you should be able to preview the schema by saying print schema instead of show. So let me say print schema here. We should be able to see the schema details. The schema details is as per our expectations. This is how you should be able to create Spark Dataframe using Pandas Dataframe. It will actually overcome the challenge of missing attributes if you are trying to create Spark Dataframe using a list of dicts. You can actually convert it to Pandas Dataframe first, and then you should be able to create Spark Dataframe. As part of this sectional module, we are going to the details related to creating the data frames in Spark. So far, we have created several Spark data frames using primitive types. The primitive types are nothing but integer, float or double, string, date, timestamp, boolean, etc. Spark also supports special data types. The special types that are supported by Spark are nothing but array, struct, and map. As part of subsequent few lectures, we'll actually go to the details about all these important and special types that are supported by Spark. When it comes to Python data structures such as list and dict, they can be implicitly converted to Spark array and map respectively. A Python list can be converted to Spark array. A Python dict can be converted to Spark map. Also, Spark supports a special type called as struct. However, we have to make sure that few classes that are available as part of Spark APIs are used to convert a typical Python data structure to struct. We'll go through all these details as part of subsequent few lectures so that it is clear for you about how to create Spark data frames using special types such as array, struct, as well as map. As part of this lecture, let's go to the details related to array type columns in Spark data frames. For that, let's first create a list by name users. The users contain 5 elements. You can see here. Each element is of type dict. Each dict contain several attributes. One of them is nothing but 4 numbers. You can see the corresponding values with respect to 4 numbers. In this case, the type of the 4 numbers is nothing but list. Now, the users list is already created. We need to make sure that row is imported. Once the row is imported, we should be able to create the data frame using users using this piece of code. It will take care of creating a data frame. The name of the data frame is nothing but users_df. Now you should be able to expand. You can see here 4 numbers is of type array. Each and every element in that array is of type string. You should be able to print the schema as well. Print schema is the function which actually gives us the schema details of the data frame. You can see all the attribute names and corresponding data types. You can also preview the data by saying users_df.show like this. As 4 numbers is of type array, you can see that the 4 numbers are displayed as part of the square brackets. Let's copy this piece of code, then add a new cell here, paste, then select only user ID and 4 numbers we should be able to say select, then user ID. It is actually ID, not user ID. Then phone numbers dot show. We should be able to say truncate equal to false, so that we can actually get complete details with respect to the phone numbers. You can see here 3 users have 2 phone numbers each. One user have only 1 phone number. One of the users doesn't have any phone numbers associated with that user. Now you should be able to get the column names by saying users_df.columns. Columns is the attribute on top of data frame. It actually returns list. This list contains all the column names that are part of the data frame by name users_df. Now you should be able to get the column names as well as data types using attribute called as dtypes, which is available on top of Spark Dataframe. You can run this. Even dtypes is of type list. However, each element in the list is of type tuple. The first element in each of these tuples is nothing but the column name. The second element is nothing but the data type of each of these Spark Dataframe columns. This is how you should be able to review both column names as well as the data types for a given data frame. When we have data frames such as users_df with columns such as phone numbers where they are of type array, we typically use explode. One of the common practice with respect to having array type columns is to explode the record which contain a column with array type into multiple records. That's where the explode comes into picture. As part of Pyspark APIs, under pyspark.sql.functions, we have a function called as explode. We should be able to use this function to actually explode the phone numbers into individual records. Now let's run this so that explode is imported. Now let's run this to see the output. Let's go to the details so that you understand the behavior of explode. If you review the original data, when it comes to the user ID 1, the phone numbers related to the user ID are nothing but 2. When it comes to user ID 2, the number of phone numbers is nothing but 2. Even for 3, the number of phone numbers is 2. When it comes to user ID 4, there are no phone numbers associated with that user. When it comes to user ID 5, there is 1 phone number as part of the phone numbers. Now, if you actually explode, there should be 2 records for user ID 1. Same is the case with 2 and 3. With respect to 5, there will be 1 record. There will not be any record with respect to 4 because the user with ID 4 doesn't have any phone numbers. You should be able to review the output here. You can see that there are 2 records with respect to user ID 1. Same is the case with user ID 2 and user ID 3. These 4 records are related to user ID 2 and 3 respectively. Then comes the last one where user ID is 5 and there's only 1 record. This is how you should be able to leverage explode on top of array type columns in Spark to actually explode the array type column values into individual records. Now let's scroll down. Let's see how we can actually access specific elements in these lists. Let's assume that each and every array will contain up to 2 numbers. The first one is mobile number, the second one is home number. If there is only one number, it is nothing but mobile number. If you want to provide aliases in such manner, you can actually use this approach. So in this case, we need to make sure that call is imported. Call is another special function that is available as part of pyspark.sql.functions. Once call is imported, you should be able to say call of phone numbers. In this case, phone numbers is of type array. For array type, you should be able to access the first element by saying of0 like this. Now I'm giving alias to it by saying mobile. With respect to the second number, we should be able to access like this. One means second number from phone numbers. We should be able to provide alias like this. In this case, the second phone number will be part of a new column called as home. The first phone number will be part of a new column called as mobile. Let's run it and let's see the details here. In this case, you see all the 5 records. With respect to 4, there are no phone numbers. That's why you are seeing nulls. With respect to 5, there is only 1 phone number. The first one is considered as mobile. You can see here. The second one is null for home. Whereas for 1, 2 and 3, we have both phone numbers, and hence as part of both mobile as well as home, we are able to see the numbers without any issues. On top of explode, there is also a special function called as explode outer. Let me copy this. Now let me paste here. Let me change this to explode outer. We should be able to import. Now let's copy this. Let's paste here. Let's see the difference between explode and explode outer. I should be able to change explode to explode outer in this case. Now if I run it, you can see that it have returned 8 records. When we use explode, it have returned only 7 records. You can actually see here, these are only 7 records. Whereas here, it have returned 8 records. All the records are same as explode except this one. You can see that the user ID with 4 who doesn't have any phone numbers is returned when we use explode_outer. This is the difference between explode and explode_outer. You should be comfortable with both the functions. They are very often used on top of columns in a Spark Dataframes where the columns are of type array. Now, as we understood all the details with respect to how to deal with array type columns in Spark Dataframes, let's go to the details about the other two special types. They are nothing but map and struct. As part of this lecture, let's go to the details related to map type columns in Spark Dataframes. In this case, I am creating a list by name users. You can see here the users contain 5 dicts. Each of the dict represents one user details. Each dict related to one user contain an attribute by name phone numbers. You can see here. However, the type of phone numbers value is of type dict. You should be able to convert the Python dict type columns into Spark map type columns. Let's go through the details so that you understand what I'm talking about here. As of now, we have created a list by name users. In that, we have 5 elements. Each element contains phone numbers. The type of phone numbers in this case is nothing but dict. Now you should be able to convert the users into Spark Dataframe by running these 2 cells. I have already ran them. You should be able to expand this to actually look at the details about this data frame. You can see that there is an attribute by name phone numbers. It is of type map. It contains 2 attributes in it. They are nothing but key and value. You can see that both are of type string. If you go to the data here, if you look at phone numbers, except for this one where there are no phone numbers, you can see that it have multiple elements in it. This dict contains 2 elements. For the first element, the key is mobile, which is of type string. The value is nothing but phone number, which is also of type string. When it comes to the second element in the dict, the key is nothing but home, which is of type string. The value is also phone number, which is of type string. As the keys and values are of type strings here, you can see that the phone numbers is created as map, where key is of type string, value is also of type string. If you have different types of values, if the values are of type numbers, then you will be seeing either int, long, or some numeric type. That being said, now users_df is created. It is of type Spark Dataframe. You should be able to print the schema by running this piece of code. You should be able to preview the data by using show like this. When it comes to the phone numbers, you can see that they are displayed as part of curly braces, and also you can see the key and corresponding value with respect to both the phone numbers. Now let me actually add one more cell here. Let me copy, paste. Let me actually say select, then ID, then phone numbers. Now let me say show. As part of the show, let's pass truncate with false. Now you should be able to preview the results to see how phone numbers are actually represented. You can see that the phone numbers contain either no elements or 1 element or 2 elements. Whenever there are elements, you have both key and value represented, where they are separated by hyphen and then greater than symbol. This is just visual representation of the data. Even internally, the data will be represented in the similar manner. You can also get the column names as well as the data types using these 2 attributes that are there on top of Spark Dataframe. When it comes to phone numbers, you can see that the type is nothing but map, where the key is of type string and also value is of type string. So map is typically used when we have varying number of key value pairs. When it comes to the keys, they are supposed to be unique. When it comes to the values, they can be anything. They might be unique, they need not be unique. Now let's understand how to access the individual values with respect to mobile, home, etc. Because if you look at the keys with respect to the phone numbers we have, the keys are nothing but home or mobile. So in this case, if I want to get only the mobile phone numbers, then I should be able to use off mobile like this on top of call of phone numbers. Then we should be able to get the phone numbers. Let me run this to import call function. Now let me say users_df.select ID, then call of phone numbers of mobile. You can see that the key, which is nothing but mobile, is passed as part of the square brackets. You can actually see the results here. These are nothing but mobile numbers of corresponding users. With respect to user ID 4, he doesn't have any phone. That's why it is returning null. Now, if you look at the column name here, it is actually saying phone numbers of mobile. If you want to rename it to mobile, you should be able to use .alias and you should be able to specify the alias. Now let me copy this. Let me add a new cell here. Let me say .alias. Let me say mobile. Now you should be able to run it. You can see that the column name is changed to mobile. In the similar manner, you should be able to even get the home phone numbers by saying call of phone numbers of home. If you wanted to specify alias, you can specify the alias. You should be able to get the home phone numbers as well. Let's try it out. Let me copy this. Let me paste here. Now we should be able to copy this, then paste here. This time we'll be saying home here. Even here I'll be saying home. Now let me actually line break. Let me also line break here. Now let me run this. You should be able to see the user ID and his corresponding mobile as well as home phone numbers. When it comes to 4, he doesn't have any phone numbers. That's why it is returning null with respect to mobile as well as home. When it comes to user ID 5, the user ID 5 only have mobile phone number. That's why you are seeing mobile number here, but there is no home phone number. This is how you should be able to access specific value by passing the key on top of columns which are of type map. As with array type columns, we should be able to use explode on top of map type columns as well. This is how you should be able to use explode. However, you will not be able to provide alias when you use explode on top of map columns. Let's go to the details so that you understand what I'm talking about here. First, let's import explode. Then let's run this. If it is array type, then you'll be seeing a column by name phone numbers, and then you should be able to see the individual records with respect to the phone numbers as part of the output. However, as phone numbers is of type map, you can see that the column names are key and value here. The key contain the keys in each and every map. The value contain the values in each and every map. As user ID 1 have 2 phones, one mobile and one home, you can actually see mobile as well as home as part of the key and corresponding phone numbers as part of the value. Same is the case with 2 and 3. With respect to 5, we have only mobile number. That's why we are seeing only that one. We are not seeing the home. Whereas with user ID 4, there are no phone numbers. That's why we are not seeing anything. You can also import explode outer. Let me actually copy this. Let me add a new cell here, paste, then import explode outer. Let's run it so that the function is imported. Now let's copy this, paste here. Now let's say explode underscore outer. Let's run this. This time you can see that with respect to user ID 4, where there are no phone numbers, we're actually seeing null with respect to both key as well as value. Whereas with user ID 5, it is only showing one phone number of type mobile and corresponding value. It is not showing nulls for the home phone numbers. As long as you have at least one element in it, it will actually return that element in the form of key and value like this. If a corresponding record doesn't contain any value with respect to the map column, then it will just return nulls like this when you use explode underscore outer. When we use explode on top of map type column, when it actually generate columns with names key and value, we might want to rename to more appropriate ones. Key can be named as phone type in this case, value can be named as phone number. If we wanted to rename key and value, then first we need to make sure that explode or explode outer is used and a new data frame is created. This will actually create a new data frame where 2 of the columns will be key and value. You should be able to use a special function called as with column renamed, which is available on top of Spark Dataframe. By passing the name of the original column as first argument and the new column name which you want to use as the second argument. In this case, key will be renamed as phone type, value will be renamed as phone number. We are also dropping phone numbers so that we don't see phone numbers as part of the final output. Now you should be able to review the output here. You can actually see that key and value are renamed as phone type and phone number. Don't worry too much about with column renamed at this time. I'll be covering all the aspects with respect to with column renamed as part of the next section or module. For now, just keep in mind that when we have map type columns, when we explode, it will generate 2 columns. One column name will be key, the other column name will be value. Many times we might want to rename to appropriate columns. In this case, they are nothing but phone type and phone number. We should be able to leverage with column renamed to actually achieve that. That being said, out of 3 special type columns in Spark Dataframes, we have already covered array and map. Now let's go to the details related to struct. As part of this lecture, let's go to the details related to struct type columns in Spark Dataframes. When it comes to struct, the column need to have predefined structure. That is the main difference between map and struct. With respect to map, the column type is nothing but map of string comma string or map of string comma int, so on and so forth. As long as the keys and values are similar type, we should be able to use map. However, if each and every record have predefined structure, then we have to use struct. That is the major difference between map and struct. Now let's review the users. First, let me actually import row, and then let me actually run this. It will actually create a list by name users. In this case, users contain dicts. Each dict is related to one user. One of the key value pair with respect to these dicts is nothing but phone numbers and corresponding values. As part of the first lecture where we have spoken about the array type columns in Spark Dataframes, when it comes to the phone numbers, we have defined it as a list type. The list is implicitly converted to Spark array without any issues. As part of the previous lecture, we have actually defined phone numbers as Python dict. A dict is converted to Spark map without any issues. But when it comes to having a column of type struct, you have to make sure that the phone numbers column in this case have a predefined structure. One of the ways to have predefined structure is by using row, which is available as part of pyspark.sql. That's why we have imported that first. And you can see that row is used. Row can take varying keyword arguments. In this case, the keys are nothing but mobile and home. The values are nothing but corresponding phone numbers. This is how we can have a pre-structured phone numbers. In this case, the structure is of type row. That being said, it is already run. Now users is created. When it comes to the phone numbers, it is of type Spark row object. It's neither a Python list nor a Python map, but it's a Spark row object. Now to create the data frame using this list, we should be able to use the similar code which we have seen earlier. Now data frame is created. You can actually get the type of phone numbers. You can see that it is of type struct. It contains two nested columns. The first one is nothing but mobile. The second one is nothing but home. Both mobile and home are of type string. So when it comes to the struct, it is nothing but a nested table or nested data frame within main data frame. In this case, the main data frame is nothing but users_df. It have one of the nested structure, which is nothing but phone numbers. When it comes to the columns with respect to the phone numbers, they are nothing but mobile and home. You should be able to see the corresponding values for mobile and home. However, there will be only one mobile and one home for each and every user as part of the users_df. Now you should be able to preview the data here. You can see with respect to phone numbers, it is displayed in curly braces. Let me actually add one more cell. Let me copy, then paste here. Then let me say select, then say ID, and then phone_numbers, then dot show. Let's say truncate equal to false. Now you should be able to see the results here. The phone numbers are actually represented in the form of curly braces. Now you should be able to scroll down. Keep in mind that with respect to user ID 4, you can see that mobile and home are set to none. Each and every column value should have a structure, then only a struct type will work. Otherwise it will not work. Now let's scroll down here. We should be able to get the details with respect to columns using this piece of code. If you wanted to get both columns as well as the data types, you should be able to use this piece of code. Now, if you scroll down, if you wanted to get mobile phone numbers, you can actually say phone numbers dot mobile. You should be able to refer to the columns that are there as part of the struct type using dot notation here. Phone numbers is the main column, then dot, then mobile. Same is the case with home. Now, if you run this, we should be able to see the ID mobile as well as home. Even this one is same. I don't know why I have pasted twice. I should be able to delete this. Now you should be able to even access mobile and home using square brackets like this. Now let's run this and then let's run this. You can see the output here. This is how you should be able to create a data frame which contain columns of type struct. Once you have columns of type struct, you should be able to use this approach to actually get the details of specific columns from the main column. You can also use star notation. So let me copy this. Let me add one more cell here. Let me paste. Now let me delete. We can actually say star here. You can run. You can see the details here. Using star, we should be able to refer to all the columns in that column which is of type struct. This is how you should be able to deal with struct type columns in Spark Dataframes. Once we go through the manipulation of columns using the functions that are available as part of pyspark.sql.functions, we'll come back to these special types again, and we'll actually perform few tasks so that we are really comfortable about manipulating the data that is there as part of the special type columns.